While experimenting with different configurations for the next all-in-one, I've come up with a little device that I call the boost box. It's basically a boost pack inside a small box with a hand crank. I'll post links to the components used in this project over at laserhacker.com. Check the video description for the link. In this all-in-one 2000, I used 72 of these supercapacitors with a folding solar panel to create a portable configuration that can power heavy loads like skill saws. This little boost box has allowed me to test whether it's practical to use supercapacitors instead of batteries in a portable all-in-one solution. The first challenge in this build was to create a secure mounting method for the hand crank generator. At this point, I've only tested one hand crank generator on this project. It didn't come with a crank handle. I found an extra handle around my shop, but it's ridiculously too small for this type of application. I plan on swapping it out for something better as soon as possible. I'm going to be testing some more hand crank generators in the near future, and if I settle on a good one, I'll put a link to it over at laserhacker.com. At this point, I wanted to test the turning direction of the crank handle in the hand crank generator. Because there's no diode between the hand crank generator and the capacitor bank, it spins like a motor when connected up to the capacitor bank, but it does allow me to see the direction of rotation. Now with the diode in place, I'm able to test the hand crank generator. It works. First I soldered the diode, then I connected the negative wire. With the negative and positive wire in place, I'm ready to wire everything up to the capacitor bank. I decided to do a quick test with my multimeter to make sure that the charging was working correctly. Everything looks good. On this build, I'm going to have two output points. One will be this 12-volt cigarette lighter socket. The other will be some heavy-duty terminals to connect up high current draw devices. This socket will allow me to plug in 12-volt to USB adapters as well as smaller inverters. At this point in the build, I couldn't wait any longer to test out this little boost box. I decided to do the first test with a USB light bulb and then see if I could power something larger. I was so excited to see something so simple work so well. At this point, I got the idea of trying to use some of the stored energy to aid in the construction of the device itself. It was a truly amazing experience to realize that the energy I was now using to build this box I had put into the system moments earlier with something as primitive as a hand crank generator. The last step was to add some battery terminal posts to this build so that I could see if this little box had the guts to start my V6 Honda Pilot. Apart from the undersized crank handle, I'm really happy with the finished project. The first thing I wanted to do was a runtime test using the new mini ultra-efficient LED light bulbs. I really like these smaller mini bulbs. They put out almost as much light as the larger 5-watt USB light bulbs, but they use a lot less energy. In this test, after running this light bulb for over 1 hour, I still had over 8 volts on the supercapacitor bank. In comparison, the standard size USB light bulb I normally use in my projects only runs about half an hour on this same capacitor bank. I really like these little voltage meters that plug right into the cigarette socket. They make it easy to monitor the voltage as I charge the unit. I also really like the LED indicators on these new balance boards. They show you when each of the supercapacitors reaches its full voltage. Now it was time to put this little boost box up to the ultimate test, to see if it could start my V6 Honda Pilot. I think it's safe to say that this is the only time the hand crank start method has been used on the Honda Pilot. There's a lot of configurations that can be tested with this little boost box. A lot of my testing is centered around determining how much usable energy is stored in one of these strings of 6 capacitors. When using a plug-in USB flashlight, this can make a pretty incredible hand crank flashlight setup. My next step will be to test a larger hand crank, and I may even need to try some different hand crank generators. My goal here is to get the charge time down around 1 to 2 minutes. With this undersized crank handle, I've spent up to 10 minutes charging the system up from a deep discharge, and that's no fun. The hand crank generator I'm using was just something I had sitting around. I'm going to go off and research and see if I can come up with a better option, and if I find something better, I'll link to it over at laserhacker.com. Well, that's it for this project. I hope you enjoyed it. Let's all keep experimenting.